welcome Mr. Yuta Nishina. He will be presenting micro-assisted carbonization of wood biomass and from the Okayama University. Okay, very good and welcome all.
Thank you very much for the kind introduction. I'm Yuta Nishina from Okayama University, Japan. My background is material chemist, so not professional microwave, but I just want to use microwave for material production, like carbon materials. But first, I'd like to briefly introduce how microwave affects the carbon. You know that I don't remember the difference correctly, but more than 10 years ago, 14 years ago, I found two interesting papers. One paper mentioned by evaluating microwave to graphite, graphite is a carbon, hydrogen carbon material, in liquid nitrogen, carbon nanoscrews are formed. I don't know what the nanoscrew means, but this is an image how graphite is peeling and making some nanoscrews. And another paper says carbon nanotubes can be oxidized by irradiating microwave. But for me, it's new, so I in my laboratory, we just try very simple equipment, and I found this phenomenon happens. I think this is normal phenomenon for you, but this is very new for me. So that's why I'm interested in the microwave treatment for carbon material. But after this treatment, material looks almost not changed. But after careful analysis, like XPS is a surface analysis for the material, and this is a starting carbon material. It doesn't have any carbon-oxygen bond. But after irradiating microwave, carbon-oxygen bond increased, and you can see some broadening of the peak, because this reaction was performed in air. But more interestingly, after this treatment, XRD shows higher intensity and peak became much sharper. This indicates crystallinity improved. So XPS suggests partial oxidation, but XRD suggests high crystallinity material is formed after this treatment. Also, during this type of experiments, unfortunately, very big paper, Science, published 8 years ago. This experiment was very simple, using graphene oxide and irradiating microwave to generate high quality graphene. Procedure is so simple. First, heating graphene oxide at 300 by conventional heating for 1 hour under argon atmosphere. And this material was put in a glass vial and argon atmosphere in a Panasonic microwave oven. I think this is just a homemade for cooking, and 1000 watts for just a few seconds, and just leaving it for a few minutes to cool down. But understanding the phenomenon, my understanding is on this slide. First, graphene oxide, this material is insulator, so microwave absorption is not so good. The first pre-treatment, 300 degrees C, it partially removed the unstable oxygen function groups, and partial graphene structure restored. And this one is still contain a lot of oxygen, but it's a little bit conductive. And this material was irradiated by microwave, and complete oxygen removal and defect repair was achieved to generate pure graphene material. We also tried a similar experiment, but in our case, we tried electric field heating and also magnetic field heating. This is a Raman spectra. Raman is a very convenient method to understand the crystallinity of the material material, and I mean kind of purity of the material. This data before means that it's a graphene oxide material. And conventional heating at 1200 degrees C, we can still see this yellow band. This band is called as defect D band, representing the defect of the material. The conventional heating doesn't change the defect amount, but a microwave electric field heating gradually decrease this peak, and around 1000 degrees C, this peak almost disappeared, and we generally use the value of IT per IG as to represent the defect amount. And this data suggests it's very, very low defect after heating. But we also try the magnetic field heating, but there is very, very limited difference. As you can see, the electric field heating ID per IG value is almost 0.12, but magnetic field heating is 0.10. So slightly magnetic field is effective for improving the quality of graphene material. And this is a high resolution TDM image. Before microwave treatment, you can see here some defects, holes, and some amorphous parts on the material. But after microwave treatment, you can see here the very clear, beautiful carbon hexagonal structure. This indicates that pure graphene structure is restored by microwave treatment. Based on this knowledge and technique, our purpose is also try to make high crystalline carbon material from wood-like woody biomass. But unfortunately, as we tried a lot of experiments and investigated the reaction conditions, but we found it's difficult to make high quality carbon material directly from wood biomass like cellulose. So as a result of our trial, we found that metal catalyst is necessary to make the high crystalline carbon material from cellulose or wood biomass. And this is from now I'll show you some movies how we prepare the carbon material in a large scale. We start from the 1 kilogram of wood powder. Then we mix with iron nitrate, iron chloride, any iron source is acceptable. But we just mixing like this with a very simple mixing apparatus. Then after mixing, we left it for one night. Then fill into the container for the preheating, because the wood biomass itself doesn't absorb microwave so much. So first we heat in this type of furnace, in general we heat at 500 degrees C, but depending on condition we can heat until 800 to partially carbonize the material. And after that, to improve the crystallinity, we irradiate microwave using this apparatus with the electric field and also magnetic field at 1300 degrees C for 15 minutes. The condition is shown here using this type of microwave system. And this is the result of the microwave irradiation. As this is the XRD patterns of the product using 1 weight percent of iron and 20% of iron. The XRD suggests a high loading of iron, shows a very sharp peak of this is the peak of graphite. So 1 week% there is some improvement of the crystallinity, and we may see some difference between e-heating and magnetic heating, but at high ion loading there is almost no difference between electric and magnetic field heatings. But anyway, a larger amount of iron loading accelerates the crystallization of the carbon material. And also, Raman analysis suggests that a large amount of iron accelerates crystallization as similar result to the XRD. And as I explained in the graphene oxide treatment, the D band, which is the kind of the defect indication of the defect, this D band also decreased after the microwave treatment, and especially high iron loading, this D band almost disappeared. And also this is almost a final slide. The carbonization of the biomass using electric field heating. This is very fascinating for me. We can see this type of plate-like product, like graphite, using microwave treatment. But H heating doesn't generate so much for this plate-like structure, similar to conventional heating. So now I believe e-heating is better suited for the high crystalline graphite materials. But this is my conclusion. Crystalline carbon is obtained by microwave heating, but effect of electric field or magnetic field is not so clear for the moment for me. So if you have some ideas or some advice, I'm very happy to accept your comments. So this is thank you very much for your
very nice presentation and very good topic on this graphene production.